Welcome back to V101 TV. I am Tim Smith at tsmith_co on Twitter, and this is episode 6 of our Introduction to VMware. Today we're going to talk about HA and DRS and some other cluster level features in our vSphere environment. Let's dive right in. You can see I already have the vSphere web client pulled up here, and we have a cluster named Nested, and I have 2 hosts in here and a couple virtual machines that I have deployed. So let's go ahead and click on our cluster, and we're going to go to the Configure tab. So these are the 2 policies, the services that we're going to enable right here: vSphere DRS, Distributed Resource Scheduling, and vSphere Availability, also known as vSphere HA. Now, DRS and HA vary slightly. HA is for host tolerance, so if you have a host failure, HA will kick in and restart the virtual machines. Distributed resource scheduling, however, will look at resource contention and migrate virtual machines over to other hosts that have a lower load. Now, obviously for DRS to work, we need to have vMotion enabled. So let's go ahead and make sure that we have vMotion enabled on both of our hosts. So be sure to go ahead and check your hosts. I have it enabled on .191. Let's enable it on 192. So I'm going to click on my host and configure. And on my VM kernel adapter, my VMK, I'm going to go ahead and make sure that vMotion is selected to be able to use that NIC. And you can see here it's going to go ahead and apply it and complete. So now we're going to be able to vMotion virtual machines between our hosts. If you're not familiar with vMotion, what it's going to do is take a live running virtual machine and move it from one physical ESX server over to the other one without any network disruption. So back to our cluster here, I'm going to go to Configure again, selecting DRS and Edit. Let's go through some of these options that we're going to see. First things first, let's go ahead and turn it on. So we have a couple DRS automation values that we can choose here: manual, partial, and full. In manual, vCenter is going to go ahead and take a look at the virtual machines, and if it sees that they're not getting the resources that they're requesting, it's going to tell you that you need to go ahead and move those virtual machines to another host. So it'll throw up a warning and let you know. In partially automated, it's going to do the same thing, but when you acknowledge that, it's going to go ahead and move them for you. And then fully automated is going to go ahead and just move them if it feels like it's needing it. We have a couple different thresholds that we can set for our fully automated environment. You can go between a conservative scale or an aggressive scale, and you can see it's going to apply different priority recommendations. Typically the default is going to be fine for most people. If you're really heavily overly provisioning your lab or your production environment, you may go a little bit more aggressive, or if you require that extra performance out, you might go a little more aggressive. It's going to do more vMotions, but it's going to make sure that the virtual machines get everything that they need. Predictive DRS is something new with 6.5. And what predictive DRS is going to do is it's going to look at some of the metrics in the vRealize operations server. So you need vRealize operations to be deployed in your environment for this to take advantage of it. And what vRealize operations does is takes a look at the overall health and performance of your virtual environment, and it's going to find a nice baseline of what should be happening. And if anything goes outside of that, it's going to let you know in warnings, errors, and you can also deep dive into a lot of the performance metrics there. But by having vRealize operations server available and predictive DRS, the vSphere environment is going to go ahead and say, hey, I normally get a big spike of performance in the next half hour. Let's go ahead and move things around ahead of time so we can guarantee that they're going to get the best performance possible. Now, I don't have vRealize deployed in this lab, so we're not going to enable that here. And a couple other options down here: VM distribution. If we check this box, it's going to go ahead and try to keep the virtual machines evenly distributed across the hosts. That way, in case one host fails, less virtual machines fail at the same time. Now, one thing that people think about when they think about DRS is that it's a load balancer, and it's not a load balancer. All it's doing is guaranteeing the resources available. So for instance, if all of your virtual machines can run in, let's say in my lab, on one host, and my host is meeting all of their requirements, then all those virtual machines can stay on that one host because they will not get a performance benefit migrating over to that other host. It's only when the ESX host cannot meet the requirements of the resources that the VMs are requesting that it then moves those virtual machines over to another host. Another option down here is power management, previously known as distributed power management. Now it's under DRS. And what DPM is going to do is go ahead and power down ESX hosts that are not needed. So if you have a large number of hosts, or if you're constantly scaling up and down VMs, depending what you set here, if your servers have an IPMI interface, or ILO if it's an HPE server, you put in your credentials and the MAC addresses here, and what's going to happen is if your virtual machines can run on 2 hosts and you have 4, then DPM might put one of those hosts down into standby mode, so you're not consuming as much power. And then as your virtual machines require more resources, DPM can go ahead and power that ESX host back on, bring it back into the cluster in an online state, and now it's usable. And next, we're going to go ahead and go to vSphere availability. So we have a couple options here, vSphere HA and proactive HA. HA stands for high availability. And what that's going to do is it's going to send a heartbeat between the management interfaces on these 2 ESX hosts. They're going to talk to each other, but they're also going to store some files on a data store. By default, you require 2 data stores. However, you can set an advanced feature to ignore that, so it only looks to 1 data store. So what happens is, if the 2 ESX hosts cannot communicate to each other over that management interface, what they're going to do is now look down to the data store. And if they're both still checking in on the data store, then they're going to realize that they're just isolated or segmented. However, if they're not also checking into the data store, the server that is still online is going to go ahead and restart all those virtual machines on it. So in the case of these 2 servers, one dies, all the virtual machines will power back on. We also have proactive HA, which we'll look at here in a second. So you can see for a failure, we have a couple different options here. Host failure response, the default is to restart our virtual machines. Isolation, now isolation is going to be when the management interfaces of our ESX hosts cannot talk to each other, but they are still all checking in on the data store. We're going to assume that the ESX hosts are still running, the virtual machines can talk to the storage, so they're running. And so what we can do is, depending on our environment, we can say, you know what, on the isolated host, go ahead and shut down the virtual machines, let them restart on an ESX host that is not isolated. Or we can go ahead and power them off. If we leave it disabled, they're going to go ahead and just stay running. We also have very similar options for data stores with a PDL, a permanent device lost. All paths down, ADP or APD. And we can also monitor virtual machines themselves by looking at the VMware tools heartbeat that gets sent back to the hypervisor. By default, that is also disabled. In the proactive HA, what this is going to do is look at health alarms. So if one of your ESX servers is sending off some health alarms, maybe from the hardware agents that are installed, maybe this is a custom ESX ISO that you installed, but ESX has the ability to see some of the host hardware level. And if there's warnings throwing up, maybe there's over temperature, array controller battery issues, and you're using the array locally there, this will go ahead and take a look at some of those warnings and say, you know, this server's not looking so healthy. Let's put it into a quarantine, and we'll go ahead and vMotion off all the virtual machines over to the other good hosts and just quarantine this one here and let you know that you need to take care of it. Now, with high availability, we have admission control. And here we're going to tell it how many host failures that we can tolerate. And we have a couple different options to set that. So a slot-based policy looks at the number of powered virtual machines and the CPU and RAM resources that are set to reserved for those, and it determines a particular slot size. It can get quite complicated in some of the calculations. The most popular one would be cluster resource percentage, where we can go ahead and say, I've got 4 hosts. We're going to look at 25%, which is going to tolerate 1 host failure. We also have the ability to just go ahead and add 1 host as a dedicated failover host, or multiple. But we can say these are dedicated failover hosts, only use them if one of our other hosts fail. Heartbeat data stores. So we talked about that HA requires a minimum of 2 data stores to look at to put its little heartbeat files on. And we can tell it to use very specific data stores. By default, it's going to use any available. And in this case, I only have 1. So under advanced options, I set this parameter, ignore insufficient HA data store, set to true. That way it's going to use our singular HA data store. So just to recap, we have DRS enabled to fully automated with the default value here of applying priority 1, 2, and 3. And we also have vSphere availability, turn on high availability. And we're going to go ahead and turn off the predictive because I don't have any hardware SIMs installed. These are virtual servers. And I'll do OK. So down here, you're going to see it's configuring HA. This is going to go out and talk to each of the ESX servers, get that HA agent installed so it can start heartbeating across to the others. At the same time, we're going to go ahead and power on some of our virtual machines here while we are waiting on HA. All right, so HA is now enabled. We can see here under it is turned on. And if we go back to our virtual machines, that's turned on. Let's go ahead and wait for this to boot up. What we're going to do is simulate a failure. So let's see what we have running here. So we have tinyVM4 is registered on 191. And both of the other VMs are over on this VM, or this ESXi server. So I'm going to go ahead and migrate tinyVM2 over to 191. Sorry. We're going to change compute only. And we're going to select our first ESXi server there, 191. It's going to validate, and we're going to choose high available. We'll finish here. So this is a small virtual machine. You can see here we're already migrated over. So what we're going to do here is simulate a failure. We have server 192 with 2 virtual machines. VM1 is running, VM3 is off. 191, you can see we have 2 and 4, and tinyVM2 is running. So now these are nested VMs. So what's going to happen here is I'm going to power off that first ESX server, 191. This is going to be identical to somebody going behind it and yanking the power out of it. So that virtual machine, nested ESXi server 1, is powered off, which is actually our 191 here. So in just a second, we're going to notice that an HA event has been initiated, and our other virtual machine, there's our alarm there. Our other virtual machine is going to go ahead and restart. Let's go under monitor. So you can see we have an HA host status error here. Host 191. Now you'll remember that, and you'll see here tinyVM2 is now off when previously it was running. And in just a second here, we should notice that tinyVM2 should be powering on its own on the good ESX server 192. All right, I had to go ahead and choose a refresh here, but you can see that tinyVM2 is now powering on. And we'll open up the console just to verify here that it is now powered on. So in just about 1 minute's time, you can see from the ESX host 191 going offline that our virtual machine obviously died with it and is now restarted. Alright, let's go ahead and bring our ESX host back online. And we're going to go ahead and fast forward and be right back. Okay, we've got that host powered back on now. You can see down here it is reconfiguring both of our hosts for HA support now that both hosts are back into the cluster. Let's go ahead and look at our VMs again. You can see we've got 2 on, VM 1, 2, and then 3 and 4 are powered off. Now what we're going to go ahead and do is try to get DRS to move some of these around. So let's go ahead and power on 3 and 4. Now with DRS enabled in our cluster, when we go ahead and power these on or register a virtual machine, it will register them on a particular host. Let's let these power on and take a look at our distribution. We can see right now that on 192 we have virtual machine 1, 2, and 4 running. And on 191 we have virtual machine 3 running. I'm going to go ahead and migrate this over to the other host. So all 4 virtual machines are going to be running on 192. You can see the vMotion is now completed. So each one of these virtual machines is running on 192. I'm going to go ahead and look at the summary. Now let's go back to our nested and we're going to look at the configuration. I'm going to set DRS to its fully automated. Now this is not a production workload, so I don't have anything taxing going on here. So I'm going to slide this all the way over to aggressive and we'll do OK. And I'm going to go over to the monitor tab in vSphere DRS. And by default, this will run automatically every so often, but I'm going to run it now to have it go check and see what's going on. And down at the bottom here, you can see now it's migrating virtual machine 2 and 3 over to the other hosts. And 3 is completed and 2 is in progress. And when you go back to the history here, you can see what it has been doing over time. So you can see at 509, it went ahead and migrated TinyVM over, TinyVM3 over. And also when they are powered on, it was placing them on particular hosts. So that's just a brief overview of what HA and DRS is for a vSphere cluster. HA, remember, high availability is when you have a host failure and your virtual machines fail with that host and then are powered back on the remaining hosts. DRS is for keeping resources in check and will vMotion those live to other hosts in the cluster. So HA is an interruption of service and a correction, and distributed resource scheduling, DRS, is a live mitigation of resource contention. So that's it in our look on HA and DRS. Be sure to click the subscribe button below and join me on the next video here on V101 TV.